All right, welcome back. Today we're going to talk about STL. STL is short for Standard Template Library. And the template is, that's one of the beauties, one of the solutions, one of the things making it so, well crafted and reusable. So, in short, there are a lot of algorithms you use a lot of algorithms every day, but you don't even think it is an algorithm. When you loop through an array or something, you do a for each, so to speak. That's an algorithm, even if it's just a simple for loop. The thing is, it's not that simple. It's not always that simple to do a for loop. I bet that it has happened to you as well as me, that you forget, to start at 0 instead of 1 or something. That's one of the most common errors we tend to encounter. Is it +1? Is it -1? And so on. And there are a lot of, there's sorting, finding things in be it arrays or be it whatever it might be, the data structure. So that's what this is all about. So and to talk about it in terms of other languages. If you use C#, you probably use link. If you used JavaScript, you have probably used map and filter and so on. And in Java, there is streams. Beautiful as well, all three of them, but it's kind of the same thing. But of course, in C++, things are, they are taken to kind of another level, and it's it's a lot weirder than in the other languages. So basically, what we will talk about we will talk about containers. We will talk about algorithms, and I think you can kind of understand. Okay, let's talk about containers first of all. It has nothing to do with Docker or anything when we're talking C++. A container is a data structure. So it could be a list, it could be an array, it could be, or for us, we in C++, we typically use vector. That's the most common used container, and then we have algorithms, and I talked about algorithms and gave you some examples. Sorting, looping, finding, reversing, and so on. So there are a lot of algorithms that are, could they be thought of kind of an algorithm should be generic, shouldn't it? Can it be generic? That's the thing. Is it the same to sort a list and a queue, or another container, an array, or what it could be? It's not completely. It's not completely clear that it's okay. So you have this algorithm and you can just apply it on any type of container you have. The thing in between is iterators, and iterators make the algorithm use the containers and so on. So the algorithm can be made. Can be made generic, and they will work on any type of container. So it's really beautiful, even though it will, of course it's C++, it will look weird in the beginning. We will also talk about one of the cool things. In almost every language now we have lambdas. So we have lambdas in C++ as well. We will talk about that briefly. Containers then. So that's what where I started. So let's just dive in to the some of the containers. These are not all of them. I mean, we have arrays, and an array. I mean, um, it's static. And it also contiguous. That's really important, that the memory is allocated after each other. And I mean, an array is, I mean, that's really the lowest abstraction over a regular C array. But anyway, we also have vectors. The cool thing is about a vector is that that's another even higher abstraction over array and regular C arrays, meaning it is dynamic as well. So this one, an array can't reallocate. It can't grow, it can't shrink. A vector can. Therefore, I mean, in I would say 99% of the cases, if not more, we use vectors. And especially considering how computers work today, and has worked for many years, with all the different caches. So we have L1, L2, L3, and so on. I mean, it has been proven that, I mean, it's almost always faster to do things in a vector than, even if it's inserting. And when inserting, it should probably be faster to do it, or deleting should probably be faster to do it in a list, double linked list. But since a double linked list is not allocated by its whole in a contiguous array, that would typically be slower, at least as long as a vector is like not more than 500,000 items. That's true, and it's been proven. So we almost always. Oh, that's funny. Okay. It's almost always we almost always use vectors. But there are some other containers, and I mean, they are, yeah, there are special use cases when we use them. I mean, sets, yeah, absolutely. And maps, yeah. I mean, a map is what we call dictionary, so it's a mapping between a key and a value. We also have, I mean, stacks. Yeah, there are special use cases, like if you're writing a compiler or anything. The queues, yeah, you could use it, but it's pretty easy anyway. When I said if you're writing a stack, I'm not. If you're writing a compiler, I'm not meaning this stack is not the memory location stack, where all the variables are stored. I mean, this stack is a data structure, and it's typically used when, I mean, a typical use case is matching parentheses. So you have parentheses and you have inner parentheses, and matching those are typically like this one. I mean, let's have a look at this one. How is it possible that this one lights up? Now, it's not that magic, because but I mean, there could also be multiples inside, but this one is still connected to this one. So that's you typically implement those things using stacks. Anyway, so there are a few containers. We almost always tend to use vectors. You shouldn't use anything else if you're not sure. I mean, yeah, maps, of course, but besides that, use a vector. Okay, algorithms. I mean, the algorithms are too many to list. Let's have a look. Here are the algorithms, and as you can see, we have sort, of course. Okay, let's start here. So we have all of, any of, none of. We have for each, we have count, we have count if, we have mismatch, we have find, and let's go on. I will talk about this later. Search. I mean, most of them, I hope you feel that most of them you can kind of understand what they do. Because they have been trying to, you know, really name the algorithms what they do. So, I mean, find or count. So count how many there are, matching a specific criteria, and you will see it will make a lot of sense when you start coding instead. But I just wanted to show you that there are so many type of algorithms which we use each and every day. I mean, when we talk about algorithms, it doesn't have to be, you know, the algorithm that Facebook uses to decide what post you will see tomorrow. It's more like, I mean, algorithms, everything is algorithms. Even a small follow-up is an algorithm. And we try to not write them, because for each line of code we write, we will introduce at least 2 errors, 2 bugs. So, I mean, we don't write for loops. We write for each, and so on. Okay, let's continue down. So we have, I mean, we have a lot of copies, replace. So, yeah, I hope it makes sense for you. So it's okay. So it sounds like if you have a vector or something, we could replace, we could copy, we could swap, we could reverse, we could, yeah, so unique. We could also, let's not talk about partitioning. We could sort, of course. And we could do binary search. That's cool. And we could, you know, use, I mean, some set operations like includes and so on. And we could do mean and max. So as you can see, there are a lot of algorithms which you might think, oh, I don't call that an algorithm, but start. Because, as I said, if you write your own for loop to, you know, accumulate or sum something up, it is so easy to introduce a bug somewhere, and it's also you typically tend to create variables and more lines that you need, and so on. So it's really a best practice to try to use this algorithm. So let's start. Okay, actually not. We need to talk about iterators. I will just talk about iterators briefly, because I mean, these are kind of weird. So the iterators, we should look at them as the thing connecting the algorithms with the containers. So when the algorithm need to, you know, do something, get the next element or get the next 2 elements, because the algorithm need to compare in the sorting or something, and also swap later on and so on. So every time an algorithm needs something from a container to go through iterators, because iterators will then work differently depending on the actual container. So that's all right. So that's iterators, and we will. I mean, I will talk about it more when we start using them. I mean, they are also so advanced we won't even try to get into those. So what we will do, we will try to. I mean, we will consider. And I will consider a real use case. That is, we have a lot of movies in a vector, and we will need to do some calculations on that vector. That's it. So I mean, typically if you Google or anything, you will get, oh, so we have a vector of ints. Yeah, how often do we have a vector of ints? Like never. We typically always have vectors of objects or something. So that's what we're gonna do. Because I mean, the school book will tell you, okay, so to sort something, it's so easy. You just need to you create the array, and the array or vector then will always be like 10 ints, and you just call like this std sort, and then it works. And it's like, yeah, of course it works, but I don't have ints. I have hockey players, of course, or movies or something. So we will very, very quickly get into the cool things, the cool thing that's lambda. Anyway, so why should we use it? I have already said that. We should, I mean, it's that code is already tested, and it's I mean, we should we should write as little code as possible. It's standard, so other developers know STL. It's also performant. I mean, it's probably more performant than the code you could write when it's possible. I mean, it's also specialized, so those iterators, I mean, there are different iterators depending on the containers. And also code readability. And in the beginning, you will feel like, oh, you gotta be kidding. But I really mean it. Eventually, when you get used to it, you see, okay, so you kind of look beyond some of the weird things, or you know, an algorithm is named after what it does. So I think it's good. All right, let's start. Actually, not with sort, but let's start with because I need to start with something more advanced because we have objects then. Not more advanced. I mean something more easy. Okay, so I was thinking we have these great movies. And now we should loop through all of them. And I would also like to, you know, print the title. Actually, what I will do, I will just, okay, let's, I will probably need getters. This should be const, of course. And a year. We will probably need them all. And the last, sorry, that should be it first. Movie type. So we have a lot of great movies. Get movie type. Like this. And type. Okay, so let's say we should print all the movies. The movies' names. Sorry, just the names. I mean, we should probably use stream insertion operators, but not. We need this. We're gonna do some cool things later, so we need this. Okay, so let's write, you know, kind of old, or should I say C type of code. So we do this. Because, you know, we do have the, sorry, I still have problems, you know, in every other language it's length, here it's size, like this. And we should get one of the movie. Actually, we should just do this now. So let's get the movie dot get name and std1 like this. All right, let's run it. And this this little program will, of course, work. It's not. I mean, it's not that hard to write, but I mean, I bet it has happened to you. You kind of like this, starting at I is as long as I is less or equal the size, or you know, you I mean, even for, and actually the semantics of this one is not the very best, because it's just a loop, and it's possible to do things like if I is 1, then let's do a break. And it's, I mean, the semantic doesn't tell you that this is wrong, because I don't know if it's wrong or not. It depends on the use case, of course. So there are options. We could, of course, do the cool new. We should do this one. And we are gonna do the great movies. And now we could this. I mean, this is of course a lot better. Sorry, I need to try to fix this blinking keyboard. It's like a discotheque. And I don't feel at home at discotheque. Okay, so now it's printing again, and you know, it's working and it's fine. And what I wanted to say is, I hope you agree with me. There is another type of semantics in this one. Here, okay, it does say this is a for loop for each loop. But I mean, let's say we need to iterate the for loop from the back to front, or you know, now I can't even think of any else way of iterating this one, but there could be, I mean, so let's just talk about that use case. We want to iterate it, do a for each, but from the back to the front. Oh my god. And we have it's not possible. So let's do it using the cool algorithm. So we always include algorithm like this. Include algorithm, and when we have include algorithm, we could do stud for each. And let's have a look at this one. And I mean, it's, I don't know if this says anything for you. It's underscore input iterator first, underscore input iterator last, and then a function, it seems, of any kind. It's really weird. So, but it's not that weird. I mean, as usual, when we I mean, one of the good things about C++ is that looking at real code often help you more than the documentation does. So let's just write an example. This example. So when we use these these algorithms, as I said, they typically work against iterators. So what we need to do is provide an iterator to the for each. And what we do is we say from where, from the beginning of the great movies. Number 2 is the last to the end of the great movies. And as you can see, you will see this into there are 2 ways of writing this. I will talk about it later. Let's just do the last one. Now we have a lambda, because you will almost always, I mean, when you look at the examples, it's so easy, and but I mean, we use, I mean, we use classes, we use objects. So let's, I don't know why I called it an M. Yeah, movie, of course. M. You know, I always think it's hockey players again. Anyway, so this is a lambda. Let's just write the code first. Like this. Great, I call it M again. Okay, here it is. So this is how the code should look. I mean, of course, it's nothing wrong with doing this. When there is a for each loop and the semantic is we should go this way, no problems. But the thing with this is we get a lot of options. So let's go the other way, iterate it reverse. So then, okay, copy and paste might not be the best thing. So let's start at end and go to begin, like this. And now we will use the same algorithm, but it will, and the algorithm will apply this lambda. We will talk about this, not in this video. Let's just say this is how we write it right now. So this is lambda, which is an unnamed function. As you can see, this is a function. It's code in here. So it's a function in that code block. Inside those curly braces, and we also have a parameter, and the parameter will be filled by this for each. So as you can see, in for each there is a for loop undercover. Of course, we don't see it. So and I mean, this is, as I said, this is there are a lot of sorry, I don't remember the name now, but it's good to do this. So there are a lot of positive effects, I should say, with doing this instead of doing this, even though this should work fine until it doesn't. Until you have to go backwards, or you know, anything. But this is how we work with it. I forgot to say or tell you this. Actually, I should of course run it as well, so we can see if it works. So let's say we need to go backwards, and we need to go forwards. Forwards and defense. I'm just kidding. Okay. Okay, let's see. There's something wrong with this. Okay, so let me see. All right, so we should start at, oh, how do you reverse? God, this is, sorry, this is so, What a shame. I was telling you this is why you should do it, and I can't even do it. I have to look it up. Let's see. I have to Google it. I mean, it's not like you do it that often. I would say. Let's see. Forwards, backwards. It says 1, and then okay. Anyway, let's not do this right now. We will look at it later. Okay. Anyway, so for now, let's just say this is how you should do it. Because, but there is another way of doing the same thing. That's where I was going. So you might see code looking like this instead of doing. As you can see, there are member function or member methods on the containers that give you the start and the end iterators like this. You will probably see this a lot, and of course it's okay. The problem is sometimes you do. I mean, you could using this way. By using this way, you could also get iterators for, you know, regular C arrays. So if you have an array like like this, I mean, with you could use std begin like this. So that's a difference. You can't do, as you see, i.begin or i.end. So it's said to be a little better this way. Anyway, that's for each. Let's have a look at another one. So let's start looking at things. I want to see if, and I mean, and now it's starting to be, you know, a lot of fun. Because it's kind of like when you learn SQL, if you do know SQL, as soon as you do, you have the power to filter and to select and to, you know, join and so on. And now we can start. I mean, we have this fantastic, really high valued data source. And now we want to start using it. So let's just say, is there any movie? Is there any movie created in 2000? And it should we should get, I mean, true or false. True or false. So we could write a for loop. Oh, we know how to do it. We could do a for each loop, right? We could do a for each loop. We could also have a bool found, and if we if m dot if m dot, as you can see, there are a lot of errors, and it kind of, will it ever work? Sometimes it will. Anyway, if get year is 2000, we could set found to true, and we could break. Cool. And I mean, that's not, I mean, that's not the hardest thing to do. I'm not saying that, but it's stupid, because as you can see, there are a lot of possible errors that could occur. So we don't do it like this. This is how we do it. Now follow me. Found equals. So there are other algorithms, and the one we are looking for right now is any of. Any of, and as before, we should have the begin or the end. This. So I mean, it will look from the beginning to the end and so on. And the last one is a lambda again. Oh, sorry. Which will be the same. Aha, I did have a, okay, that's why it's not working. We don't have to, I mean, we could help VS Code a little bit and not use auto. I could say like movie, const reference movie like this. You know, sometimes even though we want to use like this, yeah. Even though we want to use auto as much as possible, sometimes, especially VS Code, is I mean, it's so slow, and it's yeah, it's not updating as it should. Anyway, now then, we just return a predicate that is a bool. So I mean, actually, this is the predicate, and in it we return a bool. So if movie dot get year equals to, oh, did you see that? I'm coding a lot of JavaScript right now, and it's so weird. It's like, yeah, you do 3 equals. That's best practice. Anyway, actually, this is it. Just read this with me. If you kind of look beyond all the begin, and actually we will look further on how these things are enhanced and actually I mean abstracted away in C++20. But right now I'm compiling against C++17. So this is how we do it. But have a look. Follow me. Found equals. Found is set to, sorry. Any of the great movies begin and beginnings end. We get the movie, and okay, so if the movie year is 2000, then it returns true. And any of, okay, so is there any of these movies that fulfills this this predicate or this function? That's how it works, and I mean it's so readable, at least to me. And we also have, I mean, we could do all of, we could do none of, we could do also, let's see how many movies are created after 2010. Okay, so then we have the count, and we use the count. Actually, we use the count if, and if it's the year, I don't remember what I said. I think it was like this. So this one will count all movies. I mean, as you can see, there is always a loop inside, and it will count all that fulfills this this statement. Let's try it. Because it's as I said, I mean, I couldn't even make the backwards work, so maybe this won't work either. Let's see. Oh, sorry, now that was the wrong button. I need to debug, so we could have a look. Okay. So we have the count. So there are 3 movies. That's cool. I mean, isn't it? And there is a movie. Yeah, there is a movie that was created in 2000. So, I mean, as you can see, I hope you have encountered like link or map or anything in other languages. You see, this is the equivalent, the C++ equivalent. And it's not that hard. Actually, it is really, really, really hard when you start, when you start, I mean, diving into, oh, what is this? And I mean, it's not the kind of code you would, I mean, just have a glimpse at the documentation and now I can write it. But when you see code and you understand it, that's the most important thing to start with. And then you copy and paste, and then you get it to work yourself and write the code yourself. There will be a new video, another video, where we look at the other things like sorting, accumulate. We will look more at what do we have more? We have some. Let me see. Find, of course. So I mean, we should try to find a certain movie inside. And we should be able to find the first movie that was created after 2010, or find all the movies that were created. You know, find the first, or find all matching, and so on. But that's, as I said, for another video. Let's call it a day.